Hi, I'm going to share a script with you called Tertiary Education Over Time. And in this script, we're going to download a few variables from the World Development Indicators for examining tertiary education in African countries. So we're just going to slowly go through the script. I'll explain a little bit of what the commands are doing. Then I'll run them. I can't annotate it and run it at the same time. So I'll occasionally pause the script, run it, and then come back and talk about what has happened. So as usual, we have hashtagged comments for pretty much all the commands in the script. And that's very important coding practice to write a little note to yourself and to other readers of the script so that they know what's going on. First thing that we're going to do in this script is remove everything that's in our environment. So I'm actually going to run that right now because you'll see how everything that's over here in the environment window will clear away when I run it. And there we go. And I'm also going to clear out this graph here so that it's not in the way. And then we'll come back to annotating the script now. So we cleared. We are not going to set a working directory in this script because we're going to download the data from the World Bank Development Indicators server in Washington or wherever they host their data. So we don't need to load in something locally from our computer. We always have to run our library commands for the packages that we're interested in. I've installed a package called Beeper here because when we go and get the data from the World Bank, that can take a couple of minutes. And so I like to just then go and do something else on my computer, and the Beeper package will embed a little Beeper command there, so it'll ring a little chime whenever the set of commands that you're running is done. So it's very useful for not having to go back and check and for not wasting time while you're waiting for a process to run. We're going to use tidyverse a lot in this class. So it's a package of packages, and you can Google tidyverse and see what all the packages are there. And of course, the WDI package, very important for this script. We have a couple of utility commands. We're going to limit scientific notation to just for numbers that are over 9 digits. And we have a function that should be familiar to Santa Clara students from Econ 4142, a function to calculate the correct standard errors for regression analysis. And I'm just going to pause and run that. Okay, so we ran those initial commands, and now we're back looking at the script. And the first thing that we do is we create a list, a variable or an object, a WDI list, that's just going to be a list of 8 variables that we want to download from the World Bank Development Indicators. So we create that list with this C function or command, which is just what tells R to create a vector, a set of ordered characters or numbers. In this case, it's a set of ordered characters that are the names of these variables. We've hashtagged here what the variables actually mean. If you cut and paste this variable name, SETERQUATS, STMA, if you cut and paste that into Google and just search, the first thing that'll come up will be the World Bank Development Indicators definition for that variable. So it's pretty easy to see what these are and then to explore what other variables are at the World Bank's website. Then we're going to use the WDI function to tell the World Bank that we want to download all the countries, the variables that are in this WDI list that we have here. We're going to tell it to give us a couple extra variables like the region that the country's in and a few other things. And we're going to ask it to go from 1970 to 2019. And then we're going to have our little ringer, our beep device. So I'm going to go ahead and run that. And I'm going to pause because it's going to take a while and no reason. Okay, so we got the data here in our data set, and we can see 32,000 observations, 18 variables, and we can go on and look at some of the other commands that we have here. So one of the things we're going to be doing here is renaming. So we use the Dippler command rename to call these variables things that make a little more sense to the eye rather than this SE, XPD, CTER, ZS, so we can name things a little more intuitively. Then we are going to create a new data set called WDI Africa, which is just going to filter for only the sub-Saharan African region. We're going to end up then with 48 countries. We can tell how many countries by seeing what's the length of the unique country names in the WDI Africa data set. We can do a little technical thing here and see how many observations we have for all of the variables that are in the data set. And then we can run our Stargazer command, which will generate a nice looking table for just the data set for the data for 2015. And since I hadn't run what was earlier, of course, it couldn't do that. So let me run the earlier stuff and then the Stargazer, and we have a nice little table there of our data set. And what we notice right away is that there are many variables that only have a few observations for 2015. And so we certainly want to be very careful about doing any analysis if we only have 5 countries observed in the data set. We do have a lot of observations for this enrollment tertiary percent of the total, so we'll spend a little more time looking at that one, I think. So let's go ahead and see down here. We can create some plots. So I'm just going to run the first one here so that we can see what it looks like. And we run there, right? And we've got the year on the x-axis. We've got the enrollment in tertiary education going from basically 0% and you know, just a couple percentage points in 1970s up to about 15% on average. So this is the simple average. How did I create the average? Well, I used the summarize command, and then I took the mean of this variable, taking care to tell R what to do about missing observations. This is an unweighted mean, so Nigeria with 180 million people is weighted the same as Botswana with maybe 2 million people. So ideally, of course, we'd much rather have a population weighted average if we were asking what's the extent of tertiary education on the continent, right? So you might think about, well, how could I do that? How could I implement a population weighted average in R? Then we have our ggplot command, and we have the year on the x-axis, y on the or the enrollment on the y-axis using this data set ZZ, which is what we created here. We didn't have to create a separate data set, right? So we could just as easily have our command go like this. We'll do this on the fly here. So we start with the WDI Africa. We group by year. We summarize to have the average by year of the tertiary enrollment. We put another pipe in here, and take that straight into ggplot. So now we don't need to tell ggplot what the data is because the data is coming through in this pipe. And then that's all we need to do. And so we can run that. And of course, we get the exact same graph. We can go through these graphs here, right? It's the exact same thing. Notice one thing I did in this lower one, if I run it, you'll see, is it's the same graph, but now I've added a line. And this is the command to add a line of your choosing. The line I've added is just the exponential function with 5.5% as the growth rate. So I'm taking the x variable, which is the x-axis here, and saying, you know, 1971, that's 1971 minus 1970 is 1. So we have the exponential function to the power 0.055, basically means it grows by 5.5%. And we can see that that curve fits this data very nicely and fits the smooth curve that we earlier had, the Loess smooth curve. that we had. So we can take away right away that tertiary enrollments in the continent seems to be growing about 5.5% a year, right? So that's a nice, from a very low number, right? It's growing exponentially fast, 5.5%. And in 2018-19 is about 15% tertiary enrollment. And tertiary enrollment, remember, in the United States might be about 40-50%. You can go and look it up, or you can look at this same code and see what tertiary enrollment is for the United States. You notice that over here, there is a WDI US that I created along the code. So you could do the same graph for the United States and see how that's been changing over time. So there's some other functions here. I'll let you explore them and stop for now.